Alright guys, welcome back to this other part of the video. So in this part I'm going to talk to you guys. It's going to be a little short. I'm going to have kind of the full, more on, I guess, intense tricks and derivations in the description, a few notes about it. But we saw that before through a few clever tricks with the regarding the eigenvectors c and well, x psi, whatever psi, and alpha tensor beta. We managed to pull off a few tricks and gimmicks to be able to pull off this extremo Clebsch Gordon coefficient. And this extremo Clebsch Gordon coefficient, we wanted to start off with the extremo because in that way, by starting off with the extremo, as we'll see the second strategy now, by starting off with the extremo, we found that we can use these J- operators to get this full-on row of Clebsch Gordon coefficients, where each of them vary by a factor of -1 on the total angular momentum J. So J equals JA plus JB. And if we act the J- operator on it, we reduce it by integer multiples. Now, what's the other strategy? To figure out, this other side, so that then we can apply both of these strategies to get the whole table of Clebsch Gordon coefficients. The other one has to do with switching the total J, right? I guess you can see a little bit of an obvious one. And now I want to talk to you guys a little bit of a restriction here. So we before derived that J was its spectrum was half integer, but here, by switching the total J, I'm claiming that I can't go half integer multiples down or half integer multiples up, actually down, right, because this is a maximal. I can only go integer multiples down, not half integer multiples. And it's due to the following argument. So consider the following. So I alter my angular momentum by a half. Right, so it's going to be a sign of an intuitive proof by contradiction in a sense. So I alter this guy by 1/2. Well, we know therefore that that if I alter this guy by 1/2, the various options that I can have is the following. Well, if I alter this whole thing, JA plus JB, right? So to get an extra -1/2, I can, instead of having JA, I could have JA minus a half, right? And this would give me J equals JA plus JB minus a half. Or I can alter my JB angular momentum to equal JB minus a half. In either case, I can get this same result here. But notice this has the kind of domino effect of the M, the subscript here, which corresponds to the M, would then therefore have to be minus a half. That's not possible. Why? Because M goes from minus JA plus JB to plus. And it varies step by step in integer multiples, so I can't be having this 1/2 laying around, right? And why is it to JA plus JB, or up to minus J plus JB up to J plus JB? Well, because of the following restriction. MA plus MB, this was a restriction that was at least in the notes derived. M equals MA plus MB. Right, but then that implies that I can go from, because the associated angular momentum to MA, so okay, this implies the following. MA can go from minus JA to plus JA, right? And MB can go from minus JB to plus JB. I combine these two results together, I get that M goes from minus J plus JB to J plus JB, and this clearly is not an option here. I can't have a -1/2 there, so that's why the -1/2 coefficients contradict our claims that we have, so therefore they must vanish. So that's our argument. Erase this. Okay, so let's go on with the following. So we're switching it, and it's going to be switching it by an integer multiple. Okay, so now we're going to be really kind of similar tricks to how we argued knowledge of this extremo guy. We're actually going to be able to use a little different tricks to argue, and the tricks are going to be in the lecture notes, but I'm just giving you kind of the general idea. we're still going to manage to argue that how we know these Clebsch Gordon coefficients. So let's do the following. Let's now consider this eigenvector. Anyways, you guys get the Clebsch Gordon coefficient that should correspond here, right? It should have these as superscripts and subscripts, and then, you know, JA, JB, MA, MB, okay? And then it's times our other basis. So I'm scrapping out the subscripts and superscripts, but hopefully, you know, by knowledge of these guys, you can figure out what they are. Now, in this case, our sum is a little differently restricted, right? Before it was, we needed right? That was the original restriction. There was only one Clebsch Gordon coefficient that satisfied that. All the other ones vanished, or else we would have a contradiction with deriving this equality. In this case, now, we have, right, so this is a sum over MA, and this is a sum over MB. So, hold on a second, let me just look at this first. The new restriction because we switch our total angular momentum, right? Now there are two options as I just kind of looked at, right? To go from total JA of JA plus JB to JA plus JB minus 1, I could either switch my JA to equal JA minus 1, sorry, JA minus 1, or I can switch my JB, right? So there are two essentially in this whole sum, right? Because we're summing over anyway, you know the standard ranges for MA and MB, right? Likewise for MB. But notice if we have this restriction, clearly the sum from minus JA to plus JA can only contain two terms, right? Because here I have two possibilities, right? There are only going to be two Clebsch Gordon coefficients that survive if this relation is meant to hold, right? The possible Clebsch Gordon coefficients that survive are, again, I could have MA JA minus 1, right? As I glandered at here or hinted at here, or MB equals JB minus 1, right? Those are the guys that survive. So let me write that out. So what will we get if those are the two Clebsch Gordon coefficients that survive? Well, it's going to be the following. I should say not the Clebsch Gordon coefficients, but the Clebsch Gordon the linear combination of the bases. You'll get what I'm saying in a second. So this is what survives out of the whole sum. So this is one possible option. Or, and I could have the plus here. So this part stays the same. Except now instead of JB minus 1, I have JA minus 1. Right? Instead of the JB. And here in the basis that I multiplied by, it's alpha, except now up top I have JA minus 1. And the standard JB, okay? So that's that. So that's going to be part for this video. I'm going to get into kind of the trickery on as to how we can go from this Okay, so from that, I'm gonna then in the notes you can kind of describe the trickery that we can do with this, right? So in the other case, remember how we argued that that extremal Clebsch Gordon coefficient was 1 up to a relative phase, right? And that gave us information. In this case, the tricks are slightly different, but after knowing the tricks for this case, we'll manage to know the tricks for being when we're changing the other j's, right? And then so we can go like the apply j minus to apply j minus, blah blah blah, etc. Right? And so on. But that's gonna be in the notes, okay? All right, see you later.